Kia ora year 11, 12 and 13. This is a scholarship calculus question from way back in 2004, which I just realised is about when some of you were born. Anyway, it's a nice question. It's a very doable question for when we're starting off with conic sections, and we've got two in here. We've got a parabola given to us by y squared equals 4ax, and then we've got this ellipse. And A and B are positive as usual, and they meet at the points P and Q. The curves intersect in a way that the tangent to the parabola at P is perpendicular to the tangent to the ellipse at P. So Q doesn't actually come into this question at all. So let's have a wee look at what's going on here. It's going to be tipped very slightly in that direction. So I'm going to try and draw in the tangent line. And you can see that that's just not actually, so what's drawn is not accurate, right? Because you can see that the way I've drawn that, even though the tangents aren't perfect, that they're not perpendicular, right? But I want you to imagine that we've drawn an ellipse and a parabola such that they are perpendicular where they meet. Okay, first thing we've got to do is show that b squared is equal to 2a squared, and then we have to find the distance of point P from the origin O. This is going to be a simple application of Pythagoras once I've worked out what the coordinates of point P are. So two things to notice at this stage: x is positive and y is also positive. So now we should just get on with it. What we have to do is to find the tangent to the parabola and the tangent to the ellipse. So we're going to use implicit differentiation to do that. So y squared is equal to 4ax, and x squared over a squared plus y squared over b squared is equal to 1. Differentiating to get the gradient of the tangent gives me 2y dy by dx is equal to 4a. Here we get 2x over a squared plus 2y over b squared times dy by dx is equal to 0, right? So I'm assuming that you can do implicit differentiation confidently if you're watching this. There are 3 teaching videos from me on that if you need some practice. What we have to do next is we're going to find an expression for dy by dx for each shape. So here we get 4a over 2y, which is 2a over y. And over here for the ellipse, dy by dx works out to be, what have we got? Well, we're going to subtract this first. So it's negative 2x over a squared times by the reciprocal of this. So b squared over, b squared over 2y. Now, cleaning that up gives me negative 2b squared x over 2a squared y, and I can simplify out the 2's. We know that the tangents are perpendicular to each other, and perpendicular gradients multiply to negative 1. That gives us 2a over y times negative b squared x over a squared y is equal to negative 1. Let's think about where we're trying to get to. We have to end up showing a condition for b squared. So b squared equals 2a squared. In here, what am I going to do next? Negative 2ab squared x is equal to negative a squared y squared. And I'm going to divide both sides through by the negative 1, so that can go away. And all that's left to do is to realise that point P is on both those curves. And this is a really common thing that comes up in conics and coordinate geometry problems, is think about what we know. Well, we know that P is on both, and that means that we know that P satisfies both of those conditions. So y squared is equal to 4ax. I'm going to first divide through by a here, and I can do that because a is not equal to 0. So 2b squared x is equal to a y squared, which is equal to a times, where are we? A times 4ax. So 2b squared x is equal to 4a squared x. 2b squared is equal to 4a squared. So b squared is equal to 4. So whoops, b squared is equal to 2a squared as required. So that's the first part done. Now, I did that pretty slowly, but I think for most of you, you probably could have smashed that bit out faster, or certainly by November you'll be able to. Okay, so that's part 1, and now on to part 2. Now part 2 is a little bit messier. Find in terms of A, the distance of point P from the origin O. So before I start this question, I'm just going to jot down what I need to do. So 2 little steps. You don't have to do this when you're actually doing the scholarship question. I quite like doing it in these videos so that people watching can see where I'm going. And some of you will like to jot down these steps in an exam question as well. So the first thing I'm going to do is I'm going to find the coordinates of P. And then step 2 is that I'm going to use Pythagoras. And I'm looking to get this, d for distance or something, whatever you want to call it, is going to equal this, x squared plus y squared, or xp squared plus yp squared. Now I'm using that notation to indicate that xp is the x coordinate for point P. You don't have to do that, but again, with harder conics questions, that definitely can help sometimes. So we know that at P, b squared is equal to 2a squared. So we can use that fact pretty quickly. We get that xp squared over a squared plus yp squared over 2a squared is equal to 1. Now, a couple of ways to go here. Hopefully, you can spot that y squared is equal to this, and so you can substitute that straight away. If you take an extra line to get there, that's fine as well. I'm going to do that substitution now. So x squared on a squared plus, what was it again? 4ax, yep, plus 4axp on 2a squared is equal to 1. Simplifying here gives me 2, and here I'm going to leave that a squared as a common denominator for now. So I get xp squared plus 2a xp is equal to a squared, cross multiplying. I've got a quadratic, so this is pretty straightforward to solve. Don't be put off by the p subscript notation. Cleaning this up, we get xp squared plus 2a xp minus a squared equals 0. So if you've been in my class, you'll know that I'm going to do completing the square on that because this is an even coefficient. Completing the square gives me xp plus a squared minus the a squared I've added in, minus that a squared is equal to 0. Solving that gives me xp plus a is equal to plus or minus the square root of 2a squared, which is plus or minus root 2a. So we've got at this stage, we've got 2 possible coordinates for x. It's either negative a, sorry, we've lost that there. So xp is either equal to negative a plus root 2a or negative a minus root 2a, but we know that that one's less than 0, so it's not valid. That leaves me with this, and I'm going to factorize out this. So I get a into 1 minus root 2. No, you don't. Oh, that's not right. Wrong way around. Sorry, guys. Okay. Oh, something's going weird with the stylus, right? So this is a into root 2 minus 1. So that's my x coordinate, and we know that that's positive. Y squared is equal to 4ax, so 4a times a root 2 minus 1, which is 4a squared into root 2 minus 1. Now, I'm not going to go on and get a value for y because I know that I'm using this in Pythagoras. Right? So the distance from 0 to p is just going to be the square root of x squared. We just had that here. So x squared will be a squared times root 2 minus 1 squared plus 4a squared into root 2 minus 1. Now I want to clean this up because that just looks horrible. Look, you probably get nearly full marks for it, but yuck. I'm going to keep on going. So we've got a squared, which I could take out, but I haven't. 2 minus 2 root 2 plus 1 plus 4 root 2 minus 4. I feel like I've lost a bracket. I think I have. So that equals a into 2 plus 1, take away 4, is negative 1. And then I've got minus 2 root 2 plus 4 root 2 gives me plus 2 root 2. So the more elegant way to write that is just a into 2 root 2, the square root of 2 root 2 minus 1. So there you go. So that's my final distance from the origin to that point. Okay, so 10 minutes, but that question, once you get good at these questions, that question really will not take you 10 minutes to get through it. The two skills, again, that you've really got to have down are implicit differentiation, because we are finding the tangent to the curve, and completing the square is always useful in conics questions. We didn't have to use it here. We could have done the quadratic formula, but it's going to come up in the one that I'm about to video for the end of tomorrow's session. Thanks for watching. If anyone's still out there, I don't know, not chips at the canteen this time, maybe a fruit burst if you've got this far.